Hey guys, this is Carrie, and this is the answer key video for homework number 6. So, what is the remainder theorem? So the remainder theorem is if you do f of x divided by x minus a, the remainder for this problem will be equal to what you get when you plug the opposite a into the function f. We've seen that it's a really nice shortcut when you just want to know the remainder. In class on Friday, we learned about, Friday for one group, different day for another group, we learned about the factor theorem. So what the factor theorem is if f of a is 0, then the opposite, x minus a, is a factor of f of x. And this has a sort of middle step in the reasoning, right? If f of a is 0, then, let me write this in pink because this is sort of the middle step justifying this, then a comma 0 is an x-intercept. And what we saw is that when we have an x-intercept for a polynomial function, the factor x minus a is a factor of f of x. So that middle step helps justify it. So here it says determine the remainder when this is divided by x minus 2. All right, so let's see. To test for the remainder, what we'll do is we'll do f of 2. So we'll use the remainder theorem. We'll plug in the opposite value of the minus 2. So using the remainder theorem gives us 2 cubed plus 2 squared minus 10 times 2 plus 8. So f of 2 is equal to 8 plus 4 minus 20 plus 8. That all simplifies down to 0. So the remainder is 0. But this actually tells us a second fact. If f of 2 equals 0, then according to the factor theorem, x minus 2 is a factor of f of x. So by using this simple value, f of 2, we actually are able to, using the remainder theorem and factor theorem, answer two more complicated questions regarding the remainder to a division problem and also whether x minus 2 is a factor of f of x. Next up, let f of x equal this, determine f of negative 1 and f of 1. So I'll do those here and here. So f of negative 1 equals negative 1 cubed minus 2 times negative 1 squared minus 11 times negative 1 plus 12. This is negative 1. You just use your calculator to do this, but I don't have a calculator, so it's bad luck to me. And then, let's see, we get 23 minus 3. This is 20. Over here we get, for part B, f of 1. We plug in 1, we get 1 cubed minus 2 times 1 squared minus 11 times 1 plus 12. When I simplify that all out, I actually get 0. So because I have these two values, I'm able to infer stuff about whether these are factors. So when I plug in negative 1, that corresponds to the factor x plus 1 because I'll use opposite values here and here. So from part A, I can infer x plus 1 is not a factor of f of x because f of negative 1 is not 0. According to the factor theorem, f of a has to be 0 in order for x minus a to be a factor. On the other hand, because here we actually do get 0, x minus 1 is a factor, sorry, I can hear my dog barking, sorry about that, is a factor of f of x because f of 1 is 0. So this one is a factor, this one is not a factor. Let f of x be the function below. What are the factors of f of x? So the factors of f of x, we've seen in a previous unit, are going to correspond to the x-intercepts. So this is a special case of the factor theorem where we use the graph. So we have negative 5, positive 1, and positive 4. I'm visiting my parents right now. I can hear my parents talking to my dog. Oh my gosh, I hope they're not making the video. But I guess it is what it is. So if negative 5 is an x-intercept, then x plus 5, the opposite, will be a factor. if 1 is an x-intercept, then x minus 1, the opposite, will be a factor. And if 4 is an x-intercept, then x minus 4, the opposite, will be a factor. So here are the 3 factors for this function. That's great. Now it's time to do the challenge problem. So this one was optional, but it illustrates a really interesting case of the factor theorem. So, prove that f of x cannot be factored by showing that factoring by grouping fails. So, here we go. I'm going to try to use factoring by grouping. X cubed minus 3x squared minus 18x plus 40. Grouping requires me to split it down the middle. I get x squared times x minus 3 minus 9 times 2x minus 5. That's not true. That's wrong. Erasing that. Let's see. It looks like 2 goes into there. I think 2 might be the biggest common factor. 2 times 9x minus 20. Alright, so for factoring by grouping to work, we would have had to have the same factor here and here, and we don't. So, we're going to have to do something else to factor this. So we're done proving that grouping fails. Next up, determine these values, f of negative 3, f of 1, and f of 2. So I'm going to use a table to plug these in. So I've got negative 3, and to plug that in, I'm just going to do some work up here. Negative 3 cubed is there, minus 3 times negative 3 squared, minus 18 times negative 3, plus 40, and this is where I really wish I had a calculator. Alright, negative 3 cubed is negative 27. This is going to be negative 27 as well. This is going to be positive 54. This is going to be 40. Those all simplified to 40, I believe. Now I have to do the same thing a couple of other times, and you can just use your calculator for this. You really shouldn't be showing all of this work. If you plug in 1, we'll get 1 cubed minus 3 times 1 squared minus 18 times 1 plus 40. 1 minus 3 minus 18 plus 40. That's negative 2 minus 18 plus 40. That's 20. And then next up for f of 2, I'll do the same thing here. You guys can just use your calculator again to do this, but I don't have one, so I'm stuck doing it the long way. We get 8 minus 12 minus 36 plus 40. That's going to be 48 minus 48. That's going to be 0. Alright, cool. So I'm done with the long part, part B. So there's something special about one of the values from part B. So, kind of this whole idea of the factor theorem is if, when you plug in a value, you get 0, then something is a factor of f of x. Then the opposite, x minus a, is a factor of f of x. So here if f of 2 equals 0, x minus 2 is a factor of f of x. And so there's this nice idea here, which is once I know one factor, I'm going to be able to find the other 2 factors. So here's how I'm going to do it. Because x minus 2 is a factor, I know I'm going to be able to write f of x. I know I'm going to be able to write f of x. I'm actually going to write out what f of x is here. I know I'm going to be able to write x. Oh shoot! Yeah, here we go. X cubed minus 3x squared minus 18x plus 40. I know I'm going to be able to write that as x minus 2 times some other factor. So let me put that other factor in red. So to find that other factor, what I'm going to do is I'm going to use the same process we've been using for division. So I'm going to figure out that factor term by term. X times the first factor needs to be x cubed, so this is x squared. That makes x cubed. Good. That also gives me negative 2x squared. Because of that, I need to have an x factor. That gives me negative 3x squared. That's going to be negative 1x. That will be negative 1x squared. That makes negative 3x squared combined. Negative 2 times negative 1 is positive 2x. Now I want to get negative 18 here, so I need to get negative 20. So my next factor is going to be negative 20. X times negative 20 is negative 20x. That makes negative 18x, which is what we wanted from our x term. And then negative 2 times negative 20 is positive 40. And it should make sense that we end up perfectly complete without a remainder. Because if we had a remainder here, something that we were adding on, it wouldn't quite be a factor. So now how do I use this to actually completely factor it? So what I've seen here is that f of x is equal to this. So f of x is equal to x minus 2 times x squared minus 1x minus 20. It's not completely factored yet, actually, because this group here, the quotient from the previous problem, can be factored one more time. F of x is equal to x minus 2, and then using sum and product, x minus 5 times x plus 4. And the reason why we get this is if we take negative 5 plus 4, that is negative 1, negative 5 times 4, that's negative 20. So now we've got f of x completely factored. So the design here was grouping fails. Since grouping fails, plug in a bunch of random values. If one of those values gives a 0, then that is a factor. Once we know one factor, we're able to construct the other factor using this polynomial division, fill in the blanks in the distribution idea that we've been using the last, 5 classes. And once we get that fill in the blank, if we can use sum and product on that or another factoring method that we know, we just factor it, and that will leave us with our 1, 2, 3 factors. And a nice check here is we expect 3 factors because our original function was a cubic function, which should have 3 solutions for x. Alright guys, I hope this was helpful. See you in class.